Okay, let's get started. So up on the board, what you see are trig ratios. And a ratio is just comparing two things. And so this is comparing side lengths and angles. So you'll see that this little symbol right there, it's called theta, Theta, theta with a th at the beginning, not a f like F. It's a th. But sometimes that symbol could be an A or a B, which are also used to represent angles. It could be an alpha, beta. The main thing to know is that we represent angles with capital letters. So some of you like to be like, ooh, I only write in lowercase letters. Okay, well, get over yourself because we write capital letters for angles and lowercase letter for side lengths. So you need to conform, especially for those of you that are typing in your stuff to UT. They're not going to think it's cutesy because you only use uppercase or only use lowercase letters. So let's be good mathematicians and make sure that when you put the letter here, it's not a lowercase. So over here, and to be more correct, and I was typing fast, I should even be corrected. This should probably be a lowercase o and h just to help you remember that these are lowercase. Have y'all heard of SOHCAHTOA for right triangles? Okay, that's a really important thing to remember. And if you can remember SOHCAHTOA, then you can remember the reciprocals. So did anybody try the homework? And you don't have to lie to me. I don't really care. Those of you that tried the homework, did you know anything about these other symbols or these other words that they talked about? I'm just trying to get a gauge as to if you guys have been exposed to it before. Have y'all heard of cosecant, secant, and cotangent before? Okay. My guess it was no. Like most of the time when I teach pre-cal, nobody's ever heard of it. And so it's okay if you haven't. Hopefully everybody's heard of this over here and that we know sine, cosine, and tangent, their ratios are opposite over hypotenuse for sine, adjacent over hypotenuse for cosine, and opposite over adjacent for tangent. Well, all of these, sine, cosine, and tangent, they have a reciprocal identity. Do y'all remember what a reciprocal is? Maybe if I show you, you'll remember. It's when you just flip something upside down or you put it underneath one. It's like, I know that in math you've heard probably multiply by the reciprocal and you multiply by the fraction flipped upside down. So what you'll notice for these ratios, they're just flipped upside down. This one is flipped upside down. This one is flipped upside down. So that's an easy task if you can remember who pairs up with who. So the way that I remember, and I can't take credit, I swear a student or maybe the side of a book one time, I read this, but when I read it, I was like, genius. Okay, that's an easy way to remember. So one way to remember who goes with who is that each pair has only one co. What I mean by that is sine pairs with cosecant. Cosine pairs with secant, and tangent pairs with cotangent. So there's only one co in each pair. Obviously, I think that we can all pair up tangent and cotangent. Those go together. That makes sense. But if you have sine and cosine to figure out which one's pair, well, sine doesn't have a co, so it has to go with the one with a co. Cosine already has a co, so it has to go with secant, the one without a co. So that's the way that I remember who pairs up with who. And these reciprocals are abbreviated sine, cosine, and tangent. And I know that we're going to say sin, cos, and tan. It is a pet peeve of mine because like when you see MRS, does anybody ever say MERS when you're talking about Mrs.? Like the abbreviation MRS before somebody's name? We say Mrs., right? We don't say MERS. Okay, well, it's the same thing. Even though you see SIN, it's still sine. It's an abbreviation. So over here, the abbreviation for cosecant is CSC, secant is SEC, and cotangent is COT. So again, just say out the words. Say out the words. We can say it. When you see doctor as DR, we don't say der, we say doctor. It's the same thing. Let's say the whole word. So here's trig ratios. Here's just a review of a sine, cosine, and tangent, introducing cosecant, secant, and cotangent. And now let's do some stuff with it. Question number 2 in the assignment, it says, and this is representing A for an angle. It wants you to find all 6 trig ratios. To be honest, if we can find sine, cosine, and tangent, it's really easy to find the reciprocals because we just flip all those fractions upside down. So the only thing we're missing is our third side. Who remembers how to find the third side of a triangle? So I'm hearing some people say it, Pythagorean theorem, a squared plus b squared equals c squared. So we got to keep in mind that it's the 2 legs squared, added together, and we take the square root equals the hypotenuse or the longer leg. So to find that missing side length, we can do that it's going to be the square root of, what's 5 squared? 25. What's 9 squared? 81. It equals 106. Very good. The square root of 106 does not reduce. If possible, you would want to reduce it, have a reduced square root. Don't you dare give me decimals. Don't do it. So we've got our 3 side lengths. Well, we can remember that sine, SOHCAHTOA, TOA. If you want to write these down, you can. Sine is going to be, you could even put them up at the top, opposite over hypotenuse, adjacent over hypotenuse, plus you, and then opposite over adjacent. I'm going to label the triangle. If you don't know what OA and H are, then you're never going to get the trig ratios correct. So since it's talking about angle A, everything is going to be in reference to this angle. It doesn't really matter which angle you have. The hypotenuse is still the same. Hypotenuse is always across from the right angle. So across from the right angle, I can label this as my hypotenuse. What is another word for adjacent? Anybody know? Huh? Next to. So we use the word adjacent, but it just means the one next to or touching the angle. And so which number is next to or touching this angle? 5. So this has to be A. And then the other one is opposite. So it's opposite. It's never going to touch. Opposite of my angle is 9. So I have O, A, and H. So sine is opposite over hypotenuse. So from angle A, opposite is 9, hypotenuse is square root of 106. So I get 9 over square root 106. Back in ancient times, not this century, past the invention of calculators, but not in your lifetime, before you, we had to rationalize denominators. So that square root 106 would never fly. You would have to rationalize it and you couldn't leave a square root in the denominator. Our calculators are powerful now. It does not matter. And so I feel like depending on if you're looking up answers, it might show square root 106 in the denominator, or it might show it rationalized. From here, you could get some different answers. And that's okay. I'm okay with leaving it like this because I feel like I saw that in an answer somewhere they left a square root in the denominator. So just know that that is a thing. From here, cosine is adjacent over hypotenuse, so 5 over the square root of 106. And tangent is technically sine over cosine. So if you are always in the habit of writing it in this order, sine, cosine, tangent, and then the reciprocals, the reciprocal pairs, tangent is always going to be sine over cosine. So it's always going to be 9 over 5. 9 over 5. Does that reduce? No. The reciprocals, I'm going to flip all of these upside down. Okay, I'm going to show you how you would rationalize the denominator, even though I'm telling you you don't have to, but just so that you're familiar when you see some of this stuff going on. So I'm going to rationalize this one. Again, the point of rationalizing is so that we don't have a square root in the denominator. And so if I had 5 over the square root of 106, the way that you rationalize is you will multiply by the square root over itself. So what I would multiply by is the square root of 106 over the square root of 106. In the numerator, I'm going to end up with 5 square root 106. In the denominator, okay, what's going to happen is that the stuff underneath the square root, it squares. So it's going to be 106 squared and the square root of that. Square and square root cancel each other out. They're inverse operations. So then you end up with 106 in the denominator without a fraction. Just so that you know, if they start doing stuff like this is the reason why. But I feel like it's unnecessary. Okay, that's question number 2. Any questions over how to find these trig ratios? Easy peasy, right? You find the missing sides, you write your ratios. Okay, moving on. Next, this one says, given the equation, find all of the trig ratios. Okay, well, if I have sine and I have this ratio, what 2 things do I know? Think of SOHCAHTOA. What do I know if I know what sine is? I know opposite over hypotenuse. So this is the opposite over hypotenuse. I know the opposite and I know the hypotenuse. So I could draw a triangle and it even tells you, hint, draw a triangle. So if I drew a triangle, it doesn't really matter what your triangle looks like. It's just a right triangle. And so I have to put the angle somewhere. Doesn't really matter where you put it, go put it somewhere. So I'm just going to put A right there. And then I'm going to label my triangle. So I know that the opposite, so opposite of my angle right here is going to be the square root 12. The hypotenuse is 4. What will I do to find this missing side length? Pythagorean theorem, right? Yep. This time we know the hypotenuse, so we have to do the square root of the hypotenuse minus the leg. So the square root of, what's 4 squared? 16 minus, okay, what is the square root of 12 squared? What happens when you square a square root? They undo each other, so yes, it is 12. So minus 12, don't overcomplicate things. What's 16 minus 12? So we get the square root of 4. What's the square root of 4? 2. All right. Looks complicated, but actually not that bad. Sine. We already know sine, but I'm going to tell you something. I don't know. I have an issue with them leaving it as square root 12. Maybe the whole idea is that they want you to reduce it, but the square root of 12 reduces because square root of 12 is the same thing as the square root of 4 times 3. What's the square root of 4? 2. So it's 2 square root 3. So I'm not going to just come over here and write square root 12 over 4 because it's actually 2 square root 3 over 4. Does that reduce? Yes. What is 2 over 4 reduced to? 1 over 2. So this is actually square root 3 over 2. And you wouldn't see that if you left it as square root 12 over 4. Oh, I didn't even label these. So I have H, O, A. Cosine is adjacent over hypotenuse, and so that's going to be 2 over 4. Does that reduce? Yeah. Tangent is going to be opposite over adjacent. So I get 2 square root 3. Hold on. Over 2. There we go. Does this reduce? Yes. So what am I left with? Square root 3. The reciprocals, cosecant, secant, and tangent. How do I find those? What do I do with these? Flip them upside down. So I get 2 over square root 3, 2 over 1, which is just 2. And then square root 3 becomes 1 over square root 3. Beautiful. Any questions? Okie dokie. Triangles are your friends. Pictures are friends. Please draw pictures for this whole unit. Okay, next we're going to do question number 6. Number 6 says in each of the triangles, solve. Solve just means find all sides and angles. Okay, it's not asking us to write down the trig ratios. And, and they can only ask you to do this if you know 3 pieces of information. So you can only solve a triangle if you have 3 pieces of information. I only see 2. Can I easily figure out this one? Yeah, let's do Pythagorean theorem again. So B is going to be equal to the square root of 14 squared minus 3 squared, which is 9. I don't know, 14 squared. So in your handy dandy calculator, some of you have them close and you can type this in for us. Only type in the stuff underneath the square root. Type in 14 squared minus 9. Could you, if you had to, on a test, do 14 squared off on the side of your paper? Yes. Okay. Well, for convenience sake, we're going to type it in the calculator. So 14 squared minus 9. Okay, and we got to subtract 9. What do we get? not 30.
I mean, like 57.
No.
Wait, hold on. I forgot that.
It was in the 90s. It was in the 90s, so it's 187. 187. That is also a square root that does not reduce. My guess is that if they're going to have you do square roots without a calculator, which they will, they're going to give you things that you can easily do in your head. They're going to give you numbers that you can easily do math facts that are quick and easy. So we've got all three side lengths from here. We need to figure out an angle. What's the definition of a triangle? Do y'all remember the definition of a triangle as far as the angles go? They all add up to 180. So couldn't we just use trig to find one of them and then do 180 minus 90 and then minus the one we've solved to find the other one? Yes. So that's what we're going to do. It doesn't really matter if you want to solve for A or B. It does not matter. Any ideas of what you want to solve for? Solve for A. Okay, A. If I'm solving for A, would y'all rather work with a square root or whole numbers? Okay. If I am solving for A, and let me label the sides. So for A, this would be adjacent, opposite, and hypotenuse. If I don't want to work with the square root, which is totally fine because I can pick which trig ratio I use, which trig ratio is going to use opposite and hypotenuse? Sine. Okay, so then I'm going to use the sine ratio. So I have sine of angle A is equal to opposite, which is 3 over 14. Well, my goal is to find the angle. And right now, the angle is over here stuck next to sine. So the only way you can move anything across the equal sign is to do the inverse. When you're multiplying, you divide. When you're adding, you subtract. When you're squaring, you square root. Well, if I'm to have sine on one side and I want to move it to the other, I have to do inverse sine. Inverse will find angles. Inverse will find angles. So I am going to bring over the sine, and I'm going to leave the angle because like my goal is to find what is angle A. And I'm going to have inverse, which is a little -1 of 3 over 14. In your calculator, you will notice above, I don't know, the 7 or 8, somewhere around there, the 7 or 8 key, am I right? Look on your calculator. It's like 7 or 8, maybe 7, 8, 9, I don't know. Has the inverse buttons. So you're going to, oh, would we like to work in degrees or radians? What do you feel more comfortable with? Degrees. Okay, let's work in degrees. We will work in radians, but for right now, we're familiar with degrees, so let's do degrees. Yes? You could only do this with a calculator. Nope. Not like this. You're going to have trig ratios that you'll know the angle without having to use the calculator. So do you see above, I believe it's 7, 8, 9, something like that. Let's see. Above 7, 8, and 9, a couple rows up, you'll see sine, cosine, and tangent. In blue, above those are the inverses. So first you have to make sure your calculator is in degree mode. So go to mode, double check you're in degrees. I would get a different one. Make sure you are in degrees. And then what you're going to type in the calculator is inverse sine and then the ratio, 3 over 14. And we're going to round to 3 decimals. So whenever somebody finds it, let me know. Y'all agree? Anybody else that typed it in? Okay, so if we want to find B, we are going to do 180 minus 90 minus 12.374. 4. Do it and tell me what you get. $77.626. So I have just solved the triangle, and solving the triangle means that you have found all of the sides and all of the angles. Oh, I guess technically it did give you 3 angles. There's always 3 angles, 3 sides, obviously, is triangle. The 3 givens were the 90 degrees and then these 2. And so we found the other 3. So to solve a triangle, you have to make sure that all the angles, all the sides, you know them. That is solved. And utilize the definition of a triangle whenever possible. It's good stuff. We got 2 more problems that we're going to do together to kind of help remind us of trig stuff. Next is question number 10. So question number 10 says a 50-foot ladder leans against a building so that the base of the ladder is 15 feet from the building. What angle does the ladder make with the building? I encourage you to draw a picture. So that's what I'm going to do. I'm going to have a building. I've got my building. And then I'm going to have a ladder. Okay, I got my building and I have my ladder. Then I need to go through and label it with the things that it's telling me. Got my grass. All right. So a 50-foot ladder. Okay, I know that the ladder is 50 feet. Okay, ladder is 50 feet. It leans against a building so that the base of the ladder is 15 feet from the building. So the base of the ladder is 15 feet from the building. So this is 15 feet. What angle does the ladder make with the building? Now, I'll be real. I am a teacher and I'm really smart. I've earned my math degree, but I make mistakes. You'll make mistakes too. Just please read carefully. So, what angle does the ladder make with the building? I put it down here at first and went and reread the question. And I was like, that is not the ladder in the building. That's the ladder in the ground. The ladder in the building is up here. So up at the top is where I'm going to put X, whatever I'm solving for. Call it whatever you want, X, Y, Z, whatever. So I'm looking for this angle. Again, reread the question and make sure you answer it correctly. Like from here, if I have my triangle labeled from my angle, then I know, of course, this is the hypotenuse. This is the hypotenuse, and this is opposite. I don't know anything about the adjacent, so I'm not going to pick the trig ratio that has adjacent. I see people all the time solve for the missing side when you don't need to. Just use what you're given. So what trig ratio has O and H? Sine. So I have sine of X is equal to 15 over 50. We're going to solve this one exactly the same as we did the last 2 problems ago. When we want to find an angle, we have to use inverse. Inverse finds angles. So if I'm going to move over the sine ratio, I'm going to have to do the inverse. So X is equal to the inverse sine of 15 over 50. Could I reduce 15 over 50? Could I? Yes. Do I have to? No, because I'm typing it in the calculator. And Sophia, you had asked, like, how could we do this? We wouldn't have a calculator. Also, on-ramps is so big on setup. So, like, they could easily ask you a calculator question, and they're just asking you for the setup of what would you type in the calculator. So, when you type this in, what do you get? Okay, who also typed it in? Did you get the same thing? Awesome. There we go. Some problems are really easy like that. Some problems are not. So question 13 and question 15, if you struggle with those, please come and ask me. I have them worked out, but it also shows you in the answer solutions. Like it shows you all the things worked out. So again, you can use the answer key that's given. You can also come and look at my pictures and things like that to help you. How do y'all feel about this question? It was easy. Next, find the length x. So this is question 18. Find length x. So when I'm looking here at length x, this is the side length for this triangle, right? It's this bigger triangle. Is this bigger triangle a right triangle? No, you cannot use trig ratios on a not right triangle. So we're going to have to use our super skills and really break this down. And I'm going to tell you that I wrote really small. I was able to fit all of the work on here for question 18, but I wrote really tiny when I did it. So right small. We're going to have to really break it down. But first, let's look for things that we can figure out pretty easy. If I know that this is 74, can I figure out this angle right here? Yeah. It's a linear pair. Linear pairs add up to what? 180. Okay, so type it in your handy dandy calculator and tell me what this length is right here. 106. Okay, that's stuff that I can easily figure out. 106. If I know that this is 106 and this is 42, can I figure out this one? Yeah. Figure it out and tell me what it is. 32. 32. And in the littler triangle, the right triangle, if I know this is 74, can I figure out that? Yeah. What is it? 16. All right. If I know 16 and 32, can I figure out the whole length? Yeah. What is it? 48. So here's my method of attack. Because I haven't learned the skills yet to solve for this angle right here. And if you were to like chat GBT this, it would tell you to solve it using the law of sines or cosines, and we haven't done that yet. So do not just go Google answers and think that you're going to get credit for them. You have to use the skills that you know as of right now, unless you can come and walk me through it. I'm not giving you full credit for that. And there's a question like this on your quiz that you could solve a different way, but I'm not giving you credit for it because we haven't learned that way yet. What we're going to do, there's this little right triangle that actually creates this big right triangle. And if we knew this entire length down here, couldn't we just subtract off this length to find this one? Yes. So that's what we're going to do. We're going to kind of break it up. And so to do that, I'm going to have to figure out, and like I need to figure out this length right here, which I can do that already because I know this hypotenuse. I could figure out this piece right here. To figure out this piece right here. So I could call it Y. Doesn't really matter. I could call it Y. To figure out Y, I have either 16 or 74 that I can use as my angle. I'm going to use the one that's given. So 74 was given, so I'm going to figure out what y is because let's see, from y, this would be an adjacent and a hypotenuse. What ratio goes with adjacent and a hypotenuse? Cosine. So I'm going to say cosine of 74 is equal to adjacent, which is y. I'm just calling it y, over 130. How would I get y by itself? I need to get rid of 130, so I'm going to bring it over and multiply by 130. So I'm going to type in my calculator, 130 cosine 74. Enter. What do you get?
35.
Who else typed it in? What'd you get? I think I got 832. What comes after the 2? And this is a side length. It is not an angle, so I'm not going to put degrees. So I know what y is. Y is, I'm going to go ahead and label it 35.833. All right, now I'm going to try and find the length of the whole thing. I can't really do that unless I know one of the side lengths of the triangle. So it looks like I'm going to have to figure out this side length. I can do that. I'm still going to use 74, but I can call this Z. To find Z from the angle 74, because again, I'm going to try and use given information before I use solved information. So from 74, I have an opposite over hypotenuse. So what trig ratio goes with opposite over hypotenuse? Sine. So I'm going to have sine of 74 is equal to opposite, which is Z over 130. So it looks a lot like my other ratio. And how do I get Z by itself? Multiply by 130. So I'm going to type into my calculator, 130 times the sine of 74. Okay, 124.964. So that is Z. So I know this side length now. And I have some angles to choose from. I know this full angle, but I also know this one. Which one should I use? This one or this one? The one that's given. So with the given information, I know an opposite, and I want to figure out the entire length down here. I could call it W if I wanted. So from the angle 42, I know opposite, but I don't know adjacent. So what trig ratio uses opposite and adjacent? Tangent. So I'm going to have the tangent of 42 equals opposite, which is 124.964 over the adjacent, which is W. I want to solve for W. So to get W, like by itself, I would have to bring it over here and multiply. But then I've got all this stuff. So I also need to divide by tangent. So there's actually this little trick you can do. These two things can just switch places. So I get W is equal to 124.964 divided by the tangent of 42 degrees. So I will wait for you to write that down and to type it out. Ella, you got to put your phone up. Okay. Diego, what'd you get? Sophia, what'd you get? Okay. So we get 138.787, which is this whole length. So if I know the whole length now, what do I do with it? Subtract y. So x is equal to w minus y. So x is equal to 138.787 minus 35.833. Who else got that? All right, we solved for x. So some of these problems are easy, like question 10. Some of these problems require perseverance to solve them. But I think that you have all the super skills now to do this assignment. You can also do the quiz. Both of those things are due next class. That is it.